this video you will learn how friction works, hydraulic pressure works, the major components of a brake system, and how the whole system works together. One major factor that acts on a car to help it come to a complete stop is friction. Friction is resistance between two objects when they come into contact. Friction helps slow the moving objects to a complete stop. Without friction, everything in the world would always be moving and never stop. In this example, here you see the basic principles of friction at work. We can see the cube is traveling to the right. The friction would act as a force traveling to the left. This makes it hard for the cube to continue traveling, and eventually it stops it. In this next example, here you see the car rotor and the disc brake. As we see here, the car rotor is spinning counterclockwise. The friction force is applied by the brake pad when squeezed together and acts as a clockwise force against the rotor. Just like the cube, friction brings the rotor to a complete stop. Another example of friction acting on a car would be between the tire and the ground. Here we see the tire spinning counterclockwise. When the brake rotor stops spinning, so does the tire. The ground causes friction with the tire to make sure the tire doesn't slide any further and makes a complete stop. Next in this lesson is how the hydraulic pressure system works. The hydraulic system is the other main principle used in the brake system. The way it works is pressure applied to an enclosed fluid is transmitted undiminished to every part of the fluid, as well as to the walls of the container. In the example you see here, the space inside the cylinder, the fluid is becoming smaller. When this happens, the pressure inside the cylinder becomes greater. To make things easier to understand, in this example you see a small force being applied to a small area piston. That same force is transmitted to the other piston of the same size. We see that the piston on the left moves the same distance as the piston on the right because the areas of the cylinders haven't changed. Now to multiply that force from the right piston, we make the left cylinder bigger. The same force is applied as in the previous example, except the left piston is bigger and the left piston doesn't move as far. While the piston on the left didn't move as far, the force was 10 times greater because of the increase in surface area of the piston. Here we see the cylinder system connecting to the pedal and the brake pad. The brake pad has the larger of the two cylinders because it would need a greater force than the human foot can output to bring the car to a stop. This makes stopping a car much easier. Now that you have learned the basic physics of a brake system, we will show you how that applies in the major components of the brake system. It starts with the brake pedal, made up of a support axis, push rod, and pad for the foot to press. When the brake pedal is pressed, it applies a force to the push rod, which transfers the force to the master cylinder. This creates hydraulic pressure inside of the cylinder, which then is transferred through the hoses. Once the piston acts inside the master cylinder, the pressure increases, pushing the brake fluid through the hoses and onto the next cylinder in the system. This cylinder is called the slave cylinder and applies the force directly to the brake pad. The third component of the brake assembly is the brake caliper and the disc assembly. It is made up of the caliper, brake pad, and disc rotor. As the slave cylinder applies the force to the brake pad, the pad transfers that pressure to the rotor where friction occurs. Now that you know the physics and components of a basic disc brake assembly, we will put that all together for you. Here we see it starts with the pedal transferring force to the cylinder. The fluid is transferred to the slave cylinder. The slave cylinder applies force to the rotor where friction takes place, stopping the wheel. That is how a